So in this video we will study some multiple choice questions from universal law of gravitation. All these questions are from exemplar. The question number 6. In relation F is equal to G capital M into small m by d square, the quantity G, choice A, depends on the value of G at the place of observation, is used only when the earth is one of the two masses, is greatest at the surface of the earth, is universal constant of nature. It is not depending on G, so this is wrong. We are not using Earth as one of the masses, so this is also wrong. This we have not studied so far, is greater surface and all. So this we have studied is universal constant of nature. It is a constant. So D is the correct answer. D is the correct answer. Yeah, I will use this pen. So 7th one. Law of gravitation gives the gravitational force between, this law of gravitation gives the gravitational force between A, the earth and a point mass only, the earth and sun only, any two bodies having some mass. We are not worried about what is the value of the mass. Two charged bodies, no. So law of gravitation gives the gravitational force between earth, no. Earth and sun, no. Any two bodies having some masses, this is correct. Two charged bodies, we are not talking about anything charged bodies in this case. So question number 8. The value of quantity G in the law of gravitation, that is F is equal to G into mm by d square, depends on mass of earth only, depends on radius of earth only, depends on both mass and radius of earth, is independent of mass and radius of earth. So this is the equation. So depends on mass of earth only. So no, we have never talked about mass of earth. Depends on radius of earth, no, definitely. Depends on both mass and radius of earth, no. So is independent of mass and radius of earth. Any between two objects, any objects with mass and the distance between them. So this is correct. So go to the 9th one. The two particles are placed at some distance. If the mass of each of the two particles is doubled, keeping the distance between them unchanged, the value of gravitational force will be, we will find. This is like numerical, so we will solve it. So here two particles are given at some distance, placed at some distance. Distance is, we will assume it as d, and two particles. So I'll say mass of particle, both are particles, I'll consider it as same, so both are having mass of m kgs. This is meters, this is kg. Keeping the distance between them unchanged, keep this distance between them like constant. The distance is same and mass of each of these two particles is doubled. So that is, this is, I'll say m1 is mass of 1, that is initially mass m, m2 is m, m1 new value is, I doubled it, m2 new values doubled it. So now we will substitute these values. So a force is G, maybe I'll say m new I will put m2 new by d is unchanged, d square. So substitute the values. G, no need to substitute the values, we will keep it as G only. See, m1 has become 2m. m2 also will become 2m. From initially it was m, afterwards it was doubled it. By d square, I will keep it as d square only, because d is not changed. Value is not important. Here G and D, you can keep it as this one, like that only. So now 2 into 2 it is 4. 4 I will separate it. Then I will write G into G, m into m by, that is d square. Okay, initially both are mm only. So universal law of gravitation is F is equal to G. Both are masses are same, by d square. So this is nothing but 4 into the force. Only here we will call this as a new force. Correct. New force is, this is, new force is related to this. Standard force is related to this. So whatever was initially, because of this doubling of the masses, it has become 4 times the force. Okay, that is what the value of gravitational force will be. 4 times, no, 4 times, correct, not half times or unchanged, it is 4 times, correct, no, it is 4 times. Question number 10. The atmosphere is held to the earth by, atmosphere is always with the earth, it is not going away. So it's because of gravity, A, gravity, B, wind, C, clouds, D, earth's magnetic field. Definitely gravity, not wind, not clouds, not earth magnetic field. Because magnetic field attracts or it deflects only the charged particles. So question number 11. The force of attraction between two unit point masses separated by a unit distance is called what? So this also like a numerical, we will see. The force of attraction between two unit point masses. So m1 is unit. Two unit point masses. Unit is only one k. It can be anything. m2 is 1. It can be gram or kg, whatever it is. Correct. Let us take only. In this case, it is kg only. Kg only we are taking standard. Separated by distance, unit distance. So d is equal to 1 meter. So substitute these values in G, m1, m2 by d square. Okay. So substitute the values. This is the force we are calculating. G, 1 into 1 by 1. It is nothing but G. In this case, force has become G, because all are units. This is 1, this is 1, this is also 1. So everything is becomes 1. So F is equal to G. So again we will read the question. The force of attraction between two unit point masses separated by a unit distance is called gravitational potential. Still we are not studied about that, and you will study in higher classes. Acceleration due to gravity, this also we have not studied. It is not acceleration due to gravity. Gravitational field, no, it is G, correct, no? F has become G because of these values. So universal gravitational constant. So F has become equal to G. In this case, the force is equal to G. You understand? If you keep 1 kg of mass, and if it is 1 meter apart, the attractive force becomes exactly value of G. Okay, so D is the answer.